Okay, which is going. Okay, we're live on YouTube. Okay, looks like we are. If you're here, we're gonna start in a few minutes. And we'll be talking about USB and PetaLinux and U-Boot. Um, the examples today, we won't be able to go over the TFTP boot just in here, but I want to talk about more about how the PetaLinux traditional setup works. And then in the future videos, I need to figure out how to actually set up a good TFT boot option with this hardware. Because normal PetaLinux was happy with what I was trying to do. But we'll talk about that more in the next few minutes. Okay. Hello, everyone. Wave back. Hello. Okay, it looks like 10 o'clock, so we'll go ahead and get started. I'm Andrew Wilson, our FPGA zealot. Today we're going to be talking about PetaLinux, U-Boot, and USB. My hopes for this stream were to be able to demonstrate using USB peripheral interface called CDC-ECM to be able to do kind of an Ethernet over USB between a host computer and the peripheral, which would be the FPGA, be able to do TFTP boot. It looks like U-Boot supports that, but trying to set up PetaLinux to do that has been rather difficult. So we're going to walk through the basic USB flow for the PetaLinux and show you how you could talk to an SD card that's plugged in. I'm going to have to debug more. I don't think I want to look at the PetaLinux flow. I want to go look at the new Linux flow for how we would be able to support a better USB interface, be able to talk and set up Linux on this. I like to be able to do dirty builds of Linux without writing to the Flash or eMMC, be able to TFT boot. I think that's really important when you want to do low-level BSP development. You want to be able to rapidly boot to change out BSP settings or go test different BSP flows. So I want to get a TFT boot working on this board. I was not able to get a solution for this video, but hopefully we can get that in the future. Volume up, please. Okay. Turn the volume up. Okay, so that's volume up. Does that sound better? Can you hear me? Hopefully it's not too loud now, but you can adjust the volume on your side. Pass. Everyone happy? Okay. So we are using a board provided by Sundance, which has the 3. It has a relatively small MP-SoC device on it, which is dual-core application processors, dual-core real-time processors, and a pretty good size. I mean, for the size, a good size FPGA with good performance. A lot of MIPI interfaces for cameras and displays. So I just to introduce myself again, I am FPGA Zealot. We're streaming on YouTube, Twitch, and LinkedIn. I post on X. You can find me as Andrew Wilson on LinkedIn. Some other announcements. The end of next month, there is an FPGA Horizon convention conference in the East Coast of the USA. This I think will be a good mixture between industry, academia, and hobbyists. I will be attending. I just wanted to show that this would probably potentially be an interesting conference if you're in the area at the end of next month. Some disclaimers: this is not a paid sponsored live stream. I'm not employed by AMD or Sundance. I do not offer official support for these products. Content on this channel is created for information purposes only. All opinions expressed on this channel are my own. So the hardware that Sundance has provided is the VCS3 3D kit. This provides their little FPGA board, which is very compact with a good amount of hard drive space, DDR, and peripherals. It's mostly focusing on display and camera, and it's one of the reasons I wanted to focus on USB TFT booting for Linux. There's not an easy Ethernet interface to interact with, and even if you do, there's just like there's not a good place to put like a the whole Ethernet cable on the small platform. Even the expansion board, maybe you could repurpose. Maybe you could repurpose one of the MIPI interfaces and do like a Ethernet interface over that as well. But right now, there's not really an easy way to interact with TFT. I like a lot. Oh, here's more details. Here's the FPGA. We have this is the XCZU3 FPGA. Look at that. 2 gigabytes of LPDDR4, 4 gigabit flash, which is the size, and you have a good 1 gigabit QSPI, dual QSPI, which means you can boot up really fast, especially do redundancy if you want reliability. I'm not sure how you set that up, but be able to do some type of redundancy. MU, other interface. And if you want more details, you can go to the website. They have the full kit here listed. They also have the FPGA listed as well. Same block diagram, basically. And as part of this, here's some more features, right? We have the dual core ARM A53s, dual core R5s, and LPDR4, USB 3, and 154 logic cells. So I think that's a pretty good FPGA, especially for the price range. So as part of this sponsored, I guess, non-paid sponsored stream, there's a voucher coupon that you can get from Sundance. So if you are interested in this hardware, feel free to email voucher@sundance.com, and as part of being registered to this stream, you can get a 50% coupon on this hardware. So feel free to email them and to look into this hardware. I do like the FPGA quite a bit. I just need to figure out how to do TFTP boot reliably, especially with new Linux environments that AMD is supporting. As you'll see today, the PetaLinux flow is being deprecated. So what we learned today will not be available in the upcoming releases of their tool sets and tool chains. So we'll have to look at how the new environment works anyways, support the new flow. Okay. So let's go back up and talk about what we're trying to achieve. So TFT boot between the hosts. Normally when you TFT boot, you have Ethernet. We're going to say the MC, right? And using JTAG is a very slow method to load the Linux image. It takes a long time to just do U-Boot. Do a full Linux image, you can do it over JTAG. It's a very bad idea. You can do it for maybe your first image once, but you should really get a better flow. And the other more common method is TFT boot, where you would have some type of Ethernet connection here. You have the U-Boot just load the image over Ethernet over the network. But we don't have Ethernet here. We have USB-C, super speed potentially if it supports it. But we want to do what's called CDC-ECM, which then basically replicates a Ethernet interface. That situation, this is going to be a host. This is going to be the peripheral. And that's what I wanted to achieve here, but in reality, getting peripheral to work on this has been a pain in PetaLinux, and I haven't really achieved it. So we're going to have to instead probably go for a more simplistic approach of a USB flash, be able to pull off the image from the flash drive instead of using USB-C. We'll have to look at that in a future stream and figure out how to work that. We had a question about the coupon. Yeah, feel free to use this email to request a 50% coupon from Sundance for the products that we talk about in this stream. So we're going to go talk about the basic USB flow from Vivado to Vitus to PetaLinux, how we achieved getting the USB to work in the first place. And then we talk about kind of the examples for getting the other USB interface working and kind of what I played around with. So maybe troubleshooting in the future, we can try to figure out a better solution. But to begin, let's go ahead and look at the schematic. In this thing, we have the USB Type-C, and we have the high-speed and the low-speed lanes are in this interface. If we want to look at that here, This is the schematic. Here is the USB-C connector. We have a kind of like a switch box right here that's going to the high speed lane so it can support being plugged in upside down or whatnot. It's going to our transceiver bank right here. Then for the low speed lanes, which is going to be D plus and D minus right here, whether it's up, flipped up one way or another, it's going through this USB interface to a ULPI USB 5. So this is an external USB 5 using the ULPI protocol. And then right here we have USB detection that's being used for the power. So whether you get power from the main power source or whether you get from the USB. There is also a clock PHY right here. I think this, I'll look at, see if I can find where this USB ref clock is also coming from this external clock generator that's doing the GTX USB clock and the low speed USB clock as well. So there's a few different interfaces that we need to set up to get the USB working. And PetaLinux doesn't really know how to do this, especially at a U-Boot stage. So we're going to do this in the first stage bootloader. So the first thing is we need to configure the system. We're going to be using the board files. So I'll pull this up in Vivado in a second, but in the board XML, just the right place. It's going to have the configuration. It's going to have the configuration for the right here. This is the Zynq UltraScale Plus. It's going to have the configuration for all your I/O, and this USB is where it's going to have the peripheral enabled, which MIO pins you're using, where is the reset located, are using the high speed interface, which DTD lane it's on. That's where the board files are going to configure the USB correctly. And we'll just make a quick project real quick to show you how you get that going. So we're going to do a project. We're not going to specify any sources. We'll go directly to boards. If you have your board configured correctly, you can just select the VCS3 board files. Generate that real quick. Look at the USB settings. Then we'll talk about how we do the first stage bootload. It's the schematic for the FPGA board. So in Vivado, we're just going to find a block design for the top level. We're just doing the processes here, but this is where you would add any of your FPGA configuration, any accelerators. But we're just going to add IP, we're going to call it MOTSOC. And then we're going to run block automation. This is going to use the preset, right? So this is the preset that we saw on the Sundance public GitHub. And we just need to bring a clock over here and then it's happy. But we can dig down into this and look at the USB settings. There's a lot of different settings. This board supports a lot of different peripherals. And we're not using any PCIe, we're not doing any display port or anything like that. But for now, we're going to be using the USB 0. And this is the same settings that we saw on the hardware, where we're going to have USB 0, MIO 52 to 63, and GTA lane 2. And we can verify this in the schematic. Go back to the schematic. You see that we're using lane 2 for the high speed. And then for the ULPI, we have to go down to here. So this is the MIO bank number 3. We can see the ULPI interface is from 52 to 63. Yeah, 52 to 63. and verify that the pins all line up as expected. And then we have a ULP reset on MIO77 that is down here. We have an active low MIO77 reset. So this is all that's needed to configure the USB. There's additional clock configurations, like the USB ref clock. And then if we go to output clock, where is the USB here? Right here, USB 0, using a requested clock of 250. It's just for the I/O. We can see where all the clocks are defined in the system. And that should be everything we need to do to get USB configured on the FPGA. We then can export that as hardware. It basically exports to an XSA file. Show you XSA file from previous right here. So this XSA file, if let's copy it. We're going to rename it as a zip file. We can then extract all those files. And basically, this is providing our hardware definition, PSU, init scripts, which is the C that we mostly care about, and some settings. Easiest to view is definitely this HTML, which is just going to provide you your configurations, and you can verify that 52 down to 63 has been configured correctly for what we want. And then we can import that into Vitus. We imported that into Vitus in previous streams, but let me pull up the Vitus project. So here's our Vitus project. And the platform, we modified our first stage bootloader with some init scripts for the USB interface. And the USB interface is basically setting up the clock and the USB system. So it basically goes through, configures that the USB is set up correctly, that it can find all the expected statuses, sets up the clock using the clock configuration right here, which is the I2C writes for the USB-C or USB 3.0 clock generation. There's a few different ones. Yeah, so there's clock 0, clock 1, clock 6, 6, 6, 6. Go back to here. We are using the 620. We issue a reset using our MIO77 pin, and should be so that's our first stage bootloader modification. And I'll show you how we take, so when we build it, we get a output hardware, output software, boot, first stage bootloader. We're going to load this in with our process of defining the PetaLinux. So let's go ahead and do a PetaLinux image project from scratch. That over. I'm doing PetaLinux on the Steam Deck, the little easy environment we can go on. So to start, we're just going to we're going to create a PetaLinux project. We're going to just use a basic template for the Zynq multiprocessor system. Now we just need to update the hardware. Right here. So we're going to load that XSA file into our project, and this will bring in all those I/O configurations. And this is going to bring up our menu. And this is the PetaLinux system configuration. There's additional root of S configuration. There's a U-Boot configuration. There's a lot of additional settings that can happen here. For now, what we're going to do is we're going to ignore this. And it's going to set up our project. It's going to kind of, I guess, compile the configuration settings appropriately. And then we're going to modify a basic device tree to add USB to it. Then we can build. That's all you really need to get USB working. We'll show you some tricks along how we do that. So if we look at our project directory, we have build components, PetaLinux, and project spec. Project spec is where you usually add your configuration and your patches. Okay? So we have the hardware description, which is basically the extracted XSA file information, PSU, init, C, tickle, and HTML, and the system XSA. That's your hardware description that we did in Vivado. Then we're going to go back up. Okay. You do not need to use a paid Vivado license. This FPGA is covered by the free license. Okay. So actually, projects. Your configurations are in the config folder. This is mostly what we do in the GUI. So you don't normally need to manually edit these. Use the PetaLinux configuration to modify these to a GUI, but you could always modify these manually. So if we look at config, this is just has all our settings as like build parameters. You can always modify these manually, like through a text editor, or you can use the GUI. So what we're going to do is we're going to look at the kind of the patch folder. This is the meta user folder. This is where you can apply different patches. And there's different folders. We have recipes for the kernel, the BSP, and the Xilinx tools. So we're going to go into recipes for the BSP. There's two directories, the device tree and the U-Boot. We're going to modify the device tree so to where it has a USB. So in the files, there is a DTSI, which is like a a subset a subset of the device tree that's inserted into the device tree that can help modify. Right now that is blank. But what we're going to do is we're going to head into that directory, modify that file. We're going to go to project spec, meta user, recipes, BSP device tree, files. We're just going to open with Notepad. And we have this empty file. I have various examples over here. And we're just going to add this here. We have early console, tells you which settings, boot, where the root directory expects to be, and we're not going to get to this stage, so this is point we're stopping it before we get there. But we are saying that we have a USB device. So we really need to do this to set the configuration. There's other flags that we'll look at in a bit, but there's other flags for potentially trying different type of settings, and we'll look at that in the next as we play around with the hardware. But this is kind of the basic to get the USB up and running. Just setting up the WC and the USB or the U-Boot. We want the U-Boot to be able to use it. Then if we just go back to the top, we'll let this run. It's going to take a bit of time, but we're going to do right here. So we're going to do a configuration. So this should update any of our U-Boot configurations, and then it should build the U-Boot. While that's running, let's open up another session deck. Look at previously built system. Bit source our settings. 5 CD ESP 3. Okay, so here is our pre-built Linux project. So one of the ways I like to debug PetaLinux is using PetaLinux boot.h. This will help you figure out the boot options for the PetaLinux images for JTAG, and if you want to do something in a simulator of Qemu. But we're going to do JTAG, so we're going to do JTAG dash there's space got there. And there's a lot of options here. And what I want to focus on is I want to load just the kernel. I think it's the U-Boot. We just want to load just the U-Boot. So let's go here. We want to do just the U-Boot image. And we want to look at what the tickle connection for that's going to be. So what I like to do, so we're going to do PetaLinux boot. We're going to do --u boot. And we're just going to do --tickle. We're going to do stream.tickle. Does that have that? Oh, forgot JTAG. JTAG. Oh, cleaned it out so it doesn't act. We're missing. But I can show you what it's supposed to give me. Build the tickle. So let me show you what the tickle script's supposed to look like. So the tickle script is basically grabbing the power management unit firmware, loading it into a microblaze right here, the microblaze power management unit. Then we're loading the PSU NIT tickle, which sets up just basic communication with the system. Or this sets up some support for it. And then we're going to load the first stage bootloader. This situation, we're going to use the one we built from Vitus, replace it. Then we're going to do the system, device tree, U-Boot, and the DL3 one. You need to know, I don't know as much as I should about that ELF. I need to go look at what that ELF file is really doing. But this is how you set up PetaLinux over JTAG. We can go ahead and start walking through that. You know what? Acting. We're still building the U-Boot in this interface. So let's go ahead and look at that system. So we have a few things we need to manage before we can mess with or set up the U-Boot. Okay. Okay, JTAG targets. Okay, so I'm going to power cycle the hardware. We're going to use the virtual cable, the Xilinx virtual cable through the Pico 2040 that we've talked about before. And what we do is here, we go all the way to the top. I'll just show you how to connect Xilinx virtual cable URL 7001 port. Then we go JTAG targets. See the hardware on a virtual cable targets. We should see this hardware, and then we're going to load in our U-Boot system. So here we're just going to copy these commands over. We're going to load we in the wrong folder. Where are we? Are we there? Go to the right. Folder? Okay, so now we're going to load the power management firmware. We're going to load in the we had an issue. So sorry, you locked it up. We're gonna do a quick power cycle. This is the one of the annoying things about setting up the U-Boot is when you load in these L files, it puts into a rusted state. So you really have to power cycle the hardware a few times to make sure that you can do this correctly. Which I really wish I had like remote USB toggles, because it's a bunch of unplugging cables and replugging things in. I need to buy some type of controller for USB to disable and re-able the USB ports easily. So here, I'm going to rerun the command. They work this. Go. That's going through. That firmware is going through. Great. Okay, right here we can see that the first stage bootloader is enabled the JTAG, not enabled the USB PHY, set it up correctly. Audio died? Or was I just being quiet? Everyone here okay? Seems to be going good on my end. Yeah, the audio seems Okay. Yeah. I just stopped talking. So here we're going to be loading the U-Boot ELF into the system. Now when we hit continue, over here we're going to see U-Boot begin. We're going to stop it before it goes to the auto boot stage. And then we can see right here, it found USB devices. If we do USB info, we can see that it has the host controller, which is the FPGA itself. So you need to, see the interface at the memory map location, the hub that's inside the FPGA. And then here is the mass storage device. I have an SD card reader connected. So we could potentially use the SD card reader as an external memory and be able to boot off of that, which I think would be useful, which I'll probably try doing later. But I don't have the commands right now to set that up as I expect. I haven't got Ethernet to work through here, so unplug this and do a USB reset. We only see one USB device. Oh, just the hub. I plug hub in with the default settings and do a USB reset. Oh, we found cannot reset port. So let's see, we have a hub. We found the hub. We found additional interface here for power. No storage device. If I plug in Ether. Powered for the hub. It's be reset. Yeah, we're not getting. There's no Ethernet is popping up for current configuration. We can only do like a USB flash drive, and we'll have to rely on Linux to do USB Ethernet. But that's all for host, right? So in this setup, we did peripheral. What we've done is host, right? So that's the default. We want to try peripheral, but peripheral doesn't work. I'll show you what peripheral does. So we go to my Linux. I have a peripheral option here. I'm going to copy these files over. I want to show you what happens when you try to do peripheral. So the settings, the settings for host to be able to use a USB flash drive is DR mode host. Peripheral is you want to be able to use USB CDC Ethernet and be able to talk between a host and FPGA acting as peripheral. Twitch is asking, are we live? Okay, cool. Any advice on getting MAC addresses from QSpy on Pink Z2 or RDZ7? You can configure the MAC address for PetaLinux. That's one of the settings in the configuration. So if you go to petalinux-config, you can modify the MAC address. Okay. So let's see. Copy the peripheral. Restart the hardware. Everything there. We'll let that run, and I'll show you what happens when you try to do peripheral. I did finish. Any other questions about U-Boot, PetaLinux, Yocto? There's a lot of things here. BSP is complex. There's different levels you can patch. You can modify the configuration. You can modify device tree. You can patch different files within all this. You can build your own applications and embed them into the BSP. There's a lot of different ways you can approach BSPs. And hopefully the new setup is a little bit more traditional in Linux environment, but BSPs have always been kind of a big pain for me. A lot of just knowing very little and trying to get it working. I've only known a few people who dig down into it and understand it quite a bit. Oh, going straight into boot. I should. Okay, it's loading. I don't know. Is it loading from the QSpy or is it loading from something? Loading. Trying to load boot from it. It looks like it looking from MMC. Found something. Looks like it. But the important thing here is when executing this, it didn't find any USB control. Verified here. Yeah, no USB. It wasn't able to find USB devices. No Ethernet, starting USB, no USB controllers, no Ethernet found. So I need to figure out how to set up the peripherals Ethernet better. There is another configuration I want to try and show you. So we're going to look at using this. So this configuration is using all of these additional configurations. So hopefully USB gadget will help with the USB Ethernet. USB Ethernet is on by default as well. So hopefully this helps us with supporting more USB interface. Let's go out JTAG here. JTAG targets. Happy there. Go ahead and try to boot again the system. Any other questions? So we have a question from YouTube about MAC addresses. I haven't really played around with doing MAC addresses like that. I do know that there's a strong need to have consistent MAC addresses when you want to have a reliable system, be able to communicate to it over and over again over multiple power cycles. You want to be able to deploy this on multiple devices, so each device has an IP address. I currently don't know how the unique QSpy MAC is done. If I'm not sure if I assume the feature is provided somewhere. I just don't know if what you need to do to set it up. You'll find that as an issue, as we'll look here, that PetaLinux documentation is very version specific. Yeah, it looks like it didn't. Yeah, it doesn't look like it likes this up. I need to find it. Maybe the USB set that up properly. So it looks like if you're using PetaLinux, I haven't been able to see a good way to do peripheral CDC Ethernet over USB Ethernet over U-Boot. I believe it's possible. There's a lot of uh, Xilinx tutorials that suggest getting the USB configuration working, supporting what they call DFU, which allows you to do data transfers. I mean, I've tried this, still not get it working as I expect. So I'm gonna say I'm a little frustrated in trying to get the U-Boot options working in PetaLinux, but since PetaLinux is being deprecated, right? So XSD has been deprecated. All non-microblade BSPs will be deprecated in version 2026.1. The user advised to start new projects with the STD workflow. So since we need to move to a new workflow for to support future versions of the AMD tools, I think it's better to target that new workflow and learn how to use USB Ethernet peripherals in that workflow with more of an official U-Boot image. I do have examples of U-Boot images where that works, so I need to go figure out how to use that with the new tool flow and see if we can provide a better example than what Xilinx provides. A lot of these settings are specific for version. Like this is 6 years old. It Not all the settings carry over anymore. This is where was this? Where's this modified? This was updated, relatively recently. But that's for other settings. But I've tried to follow these different examples, these different forums and tutorials, and they seem to be version locked for Vivado. I mean, for PetaLinux, which makes it difficult to use those makes it difficult to support PetaLinux. But if we look at, let me pop over and open up the what the new flow is. AMD FPGA Linux. To show you what the new flow looks like. So if we go to PetaLinux tools, we go to where's the download for it? Where is downloads right? If we go to download for PetaLinux, we have under embedded software, starting with 2024.1, are entering maintenance mode. Please consult this. So now we have the embedded development framework, EDF, right? So this is how we should be using their FPGAs if we want more modern support, which is using a system device tree flow with the Octo environment. So we need to look at how this flow works, be able to follow the tutorials here to set up the USB-C for the U-Boot. So I think that's my plan, is to learn that I want to get this working on EDF rather than PetaLinux. You still can do basic PetaLinux images, but not supporting the USB flow that I desire for my device. Okay. Sorry, this is kind of me just talking, I guess, about how I really wanted this to work, and PetaLinux didn't make that very possible. I wish that worked out of the box. Happy. So I will go in a future stream look at the EDF Linux flow supported by Xilinx. So we can look at what's the official new tool, how do we use it for these FPGAs, and how do we get boot. So I want to support the USB Ethernet gadget model. Um, Communication device control, Ethernet control model. So I want to explore how we following U-Boot off some a clone of the upstream repo, patches for development boards. Yeah. So U-Boot looks like it supports what I want to do. I just need to go figure out how to do it with the new. So I'm going to say that PetaLinux is we can do USB host mode with a flash drive, and that seems to be the option I would suggest at the moment. We want to do MPSoC in host mode and in flash drive. We're going to try to look at then we can try to get the peripheral interface working in a future video, because I think that's really necessary to with something you don't have easy access to Ethernet. It'd be great if Ethernet just worked with like the basic firmware that you loaded, and then you can modify U-Boot through a terminal, like either a serial terminal or Ethernet interface over the USB. This can be used to update the various locations you can store a flash image. You can store a basic Linux image here. You can store multiple Linux images here and be able to switch out which one you want to use. Um, so I think that would be useful. That's probably where we're going to end for today. Hopefully, I can investigate more of the Linux flow. We can have some more advice in how you deploy to a small platform like this that doesn't have all the I/O available. Feel free to use this voucher if you want to get 50% off any of this hardware. And thank you for watching. This is FPGA Zealot. Feel free to follow, like on YouTube, Twitch, LinkedIn, or X. And hopefully next time we can dig more into the FPGA video processing pipeline and look at Linux, how we deploy the new Linux platform onto this small FPGA board. And thank you for watching, even though this was more of a video of me rapidly going through how you set up PetaLinux for U-Boot and USB, but not be able to get the TFT boot that I wanted. So thank you for sticking along for that. We will have more videos coming up next month. I've been sent other development boards to be able to look at, so hopefully we can have more diverse content. So feel free to leave a comment on what content you want to see, what FPGAs you're interested in, what applications you're interested in. Hopefully we can use that as feedback in upcoming videos for the next few months. Thank you for watching. I'll leave it up for a few more minutes in case anyone has additional questions or comments. I know the delay on the streaming services can be a few minutes. Okay. Thanks again. I will see you probably in 3 weeks. Probably 3 weeks until the next video. I will post on social media when those events come up. But thank you for watching. Feel free to join the Discord, join our conversations, and ask questions. Until next time.